So the next presenter is called Zhassulan. Did I get it right?
Yes, yes.
Okay. He came all the way from Kazakhstan just for this presentation, so please give him a little love from us.
Thank you very much. Thank you for this conference for organizers, and you are welcome to my last research. I presented some steps of this research in different conferences, but the my last results are presented in Zagreb the first time. So I don't like to doing presentations and slides, but I try harder and doing my best. So to be honest, I don't know that I wouldn't hear so often today word cryptography. So let's begin. Today a little bit introduced about me. I'm a mathematician. I'm a cybersecurity enthusiast, and nowadays I wrote 2 electronic books about how to create malware and how to analyze it, how to create some cool things for detecting malwares, and so I will also contribute Malpedia project, and also working on NSSP research laboratory in Kazakhstan and web security company from Netherlands. Today, I just first of all, I think we will talk about cryptography. Traditionally, cryptography we are using is for defensive, yes, for defensive security, for protecting useful information, and sometimes we are using this all of our life for IoT devices. Every protocols nowadays in internet we are using cryptography, but nowadays also cryptography is used not only for defensive, not only for secure data. It's also used for offensive for malware authors. So for example, ransomwares, backdoors, something like cryptojacking attacks, and nowadays we think that it's only used, most often used by APT groups and state-sponsored hackers. So first of all, a little bit say about antivirus evasion tricks in malware development. You know, it's first of all, of course, it's time distortion. Then function call obfuscation, when you use obfuscating Win API functions for hiding from security measures and malware analysts. Also using string obfuscation and encryption. For example, you are hiding strings like kernel32 or something like NTDLL from malware analysts, and of course payload encryption and syscalls. But today I will consider especially for payload encryption case. So traditionally we use most often classic trick is using XOR encryption for encrypting payloads. We have 2 different implementations used by malware authors. It's one single byte and multi-byte XOR encryption. Also, XORing is perfectly balanced for malware authors because they can just decrypt XOR for using one function, and you are hiding only one function from malware analysts. But XOR encryption is usually used most of malwares in today, so so easily detected. So what about RC4 encryption? Yes, RC4 encryption is also today one of the classical trick, because what I mean when I say it's classic trick, because it's also easily detected. It's also well known. For example, it's used in Metasploit for easily re-implemented also, because in many times ago I used it not only for RC4, it's used in combination with another encoding, for example, murmur hash or ND5, base 64, base 85, something like this. Okay, next one is a not so popular trick, which used by Lazarus APT group. They used a UUID from string A win API for used for decoding payload data. It's so useful for malware authors also because this function is not only decode data as well as they write it to memory. So you can just run this function for writing payload and run your payload for malware actions. So, but it's also used and re-implemented too often by Lazarus and easily detected. So I just ask myself, what about if you use non so popular algorithms, non-XOR, not AES, not RC4? So trying to different algorithms from Bruce Schneier's book, Applied Cryptography, and try to answer two main questions, and what's going on with Shannon entropy when we use different cryptography algorithms for encryption payload, and how does this affect in VirusTotal score, detection score? It's so let's begin. In this case, in this research, I'm using classic injection technique with virtual AlloX, with write process memory and create thread, and sometimes use with running payload with Win API callbacks like enums, desktop A, or maybe another callback functions, and encrypt a payload. What's the trick? We are encrypt payload via C or C++ or Python and just decrypt it dynamically in our proof of concepts. First of all, I just started with Z85 encryption algorithm, which used by 0MQ product for this protocol. And thank you to Artyomkin from GitHub. They one of the good and simplest implementation, which is used by me. So as a result, as you can see, Shannon entropy is not so high, and a little bit more than 6. That one, and VirusTotal score is reduced from 16 to 40. In this case, I used classic injection method. Next one is what about tiny encryption algorithm, which was discovered many times ago, many years ago, and used as block cipher for example, this encryption algorithm we use today not only programming way, but also for hardware encryption. And in my case, I use implementation which used case size 16 and 32 rounds implemented in C. One more interesting moment that when we not use Windows Crypto API for using some different unpopular algorithms, we are reduce VirusTotal score more than 10, sometimes more than 5 detections, as you can see. And Shannon entropy is also not so big and not so sophisticated for blue teamers, for malware analysts. The next one is protocol is A51, which use it for GSM encryption. It's not used for another cases first time, and also not discovered, and this algorithm was closed. But after reverse engineering and some hacking these algorithms, it was public in 1998, I think. And I just implement simplest case with 3 constants which use or 0. And it's also reduce VirusTotal score from 31 to 21. And as you can see, Shannon entropy is also not so big, a little bit 6.29. But what about another algorithms? For example, Madryga encryption, which was released in 1964. So this block cipher is used first time for trying to defeat another algorithms, like for using in advanced encryption standard in USA. And why not? I just trying to encrypt this algorithm also for re-implement it myself without using any Win API, crypto APIs. So as a result, this also reduced VirusTotal score from 31 to 17, as you can see. One more caveat with this algorithm, that when you use different implementation, for example, not only 16 rounds, if you increase rounds, we also reduce Shannon entropy, not reduced Shannon entropy at highest than 6. It's near 7, I think. And VirusTotal score is very horrible for this implementation when you increase rounds. The next one is DES encryption. Yes, of course, DES is not used traditional cryptography. Most of these algorithms are not used for defensive security because it's some weaknesses, and many cryptographers and cryptologists found vulnerabilities in these protocols and encryption algorithms. But why we can't use it for encrypting payloads, for detecting, for using this also for command encryption, for example, for command and control also. And this algorithm is, as you can see, it's good, showing good result. And one more caveat about A51. In this case, this algorithm, in real case, use it for one of my pentest engagements and red team operations, and bypass Kaspersky EDR. I was sent them about this, but I think nowadays it's not worked so perfectly. The next one is Skipjack algorithm. Skipjack algorithm is designated with by a National Security Agency and declassified in 1998, I think. And I'm using optimized implementation, which optimized by one of the cryptographers like Paolo Barretta. And this algorithm is also show good entropy and reduce VirusTotal score. But first question is why we not use not optimize it, maybe why we not use another implementations which can show another different results. For Skipjack, it's a little bit harder to implement it for software implementation, because most of cases this algorithm is used for hardware encryption by NSA and declassified. And one of the last results is of this research is using RC6 algorithm, and because one of my readers asked me why try to use this algorithm with different P and Q constants. This constants used for finding phi and psi constants and other constants. And this algorithm is also show good Shannon entropy result. It's most of these algorithms, as you can see, is used as for payload encryption and show good result for Shannon entropy and for VirusTotal reducing task. And what about using these different algorithms for C2C commands for encryption, URLs, strings, APIs, hashing some Win API calls? For example, when you use Telegram API, Discord, and Slack API for proof of concept, I just create little bit cases, something like keyloggers, which use Telegram API, Discord API, and Slack. And the last one is using GitHub also API. And as you can see, it's good result for reduce VirusTotal score, and I think it's one of the best results because these 10 antivirus engines are use same logic for detecting it, because they detecting everything is a little bit malicious, it's detecting all. So and the last one is what about ransomware simulation case? Yes, we know we can use encryption for payload, we can use cryptography for payload encryption, but it's not enough for red team operation. It's not enough for real life cases. For example, when you work with advanced persistent threat and state-sponsored hackers, most of them use this for file system encryption. So for in my case, I used same algorithms like Trini encryption algorithm, Madryga algorithm, and A51, for example, for encryption entire file system. Of course, with exclusions like Windows system folders, but this research is one more caveat. When you use ransomware logic vulnerable by design, you can little bit defeat it and try to decrypt it. But nowadays I'm working on decrypting these ransomware attacks. It's so headache and so hard, but I try harder. And also to do trying to use elliptic curve cryptography. For example, in real life, Babuk ransomware use elliptic curve cryptography for the victims. And thanks for my friend from WebSec Security for researching this ransomware simulation. And I'm trying to develop proof of concept to create, of course, for educational purpose, for research purpose only, and ransomware engine, which used for encryption entire file system. But I am considering different cases when you are use ransomware which vulnerable by design, vulnerable by logic, some logic. For example, if you show source code of Conti leaks, Conti ransomware, they also use one of the bulletproof algorithm for AES for encryption file system of its victims, but they have different logic vulnerabilities and logic cases when we can attack to ransomware logic, not trying to decrypt algorithm, trying to injecting DLL for ransomware, injecting to trying to hacking ransomware engine. For example, when you click, try to send some BTC to Tor domain of authors of ransomware, we can inject it. We can try to defeat logic of these ransomwares. So finally, I just show that. But what about trying to create everything and checking everything in local lab? And of course, I use Kali Linux and Windows virtual machines. And because most of case, VirusTotal score is showing some false positives for non popular cryptography algorithms. Sometimes VirusTotal show that some antivirus engines are detected, but in real cases, as you can see, for example, in Windows Defender, we are bypassing Windows Defender. Sometimes we bypass Kaspersky and Bitdefender. And I'm wondering that ESET NOD32 engine is one of the hard to bypass with non-popular cryptographic algorithms, and it's interesting case. And also I use just Python script for Shannon entropy, because it's also sometimes when you use different combinations of different rounds of encryption, we are showing different entropies and Shannon entropies. And so I use Python because it's good libraries for working with scientific calculations like entropy, like they have many libraries like NumPy, SciPy for calculating different math constants. Of course, conclusion, I think finally I just show that that today cryptography can still be used for antivirus evasion and still be used for C2 encryption, for encryption commands, URLs, as you can see. Also can use for trying to encrypt payload. And if we summarize this research, unpopular algorithms are almost always get better result than well-known algorithms in red team operations, and also useful for ransomware simulation and adversary simulation purpose, and red team operations also. So thanks. If you have some questions about this research, you are welcome.
Hi. So the question is about Shannon entropy. As you said that 6 point something is not that high number. Can you give some comparison with
for example, in most cases, security engines and antivirus are mostly detected and tag P files and different files as malicious if Shannon entropy is more than near than 7, more than 7. It's also detected, all time detected as malicious. If in some cases you can use not malicious actions, you can use just some cryptography actions and payload cryptography actions and Shannon entropy is high, and antivirus say that it's malicious and sent immediately to counting these files.
Okay, thanks.
Anyone else?
I have a question.
Okay.
Also about the entropy. As I understand, it's measured in bits per byte in this case.
Yes.
Right.
Yes.
If it's too high, it basically means data is random and something like compression or encryption. So, like you said, it's getting detected. Why in your examples it becomes slower? It becomes around 6. It would be the case, for example, for base 64 encoding of encrypted data. But in your examples, you used strong ciphers, which I would expect to provide entropy basically near 8. And why isn't it the case?
Yes. I just want to show if we have a worst scenario for attacker, worst, which when he try to use just only encryption without, for example, in real cases we are using, for example, triple base 64 encoding combination with encryption, but in this research, I just want to show how it's goodness of results when you use the worst scenario for attackers, not using encoding and not using combinations of encodings with encryption. Just only encrypt and just only use block ciphers most of case. Or you are divide your payload to blocks and try to encrypt every block without using it with encoding, additional encoding. It's worst scenario.
This is why I don't understand why the numbers are so low. If you do just encryption with a strong cipher, you would get basically 8. So maybe you just calculate entropy over not only the encryption result, but also or maybe over the entire program, including PE header and the code that implements decryption and so on. And maybe the encrypted portion is like 3/4 of the total size, and that would explain.
Good question. I don't know. Good question.
Okay.
Have you run your script over the whole file or just the encrypted data, the Shannon script?
Only for headers, only for P headers, and P sections. Well, sometimes we checking P sections. If some sections are get high entropy, I measuring arithmetic mean and sometimes in geometric mean. But I not trying to measure when we use entropy when we calculate entropy for another new sections. For example, some real-life malwares create own sections additionally, and your arithmetic mean of this is so low for all cases because you are using more sections, and so when you divide it, you are divide to high number, and your arithmetic mean is every time is low. So arithmetic mean of entropies.
Okay, thank you very much. And I guess suggestion, if you repeat this talk or continue this research, which you intend to provide more detail on your methodology, what exactly you are measuring, that would improve understanding by the audience. Thank you.
Okay, thanks.
Anyone else? Thank you for this concise presentation, and we are up to next.